Okay, we are doing 9.6 where we are learning how to do the binomial distribution and the geometric distribution using RStudio. Make sure you have your calculator handy as well because I'll be double checking the answers to make sure we are getting the same thing on our calculator that RStudio gives us. So we really won't be using a data file. We won't be using any of the folders. We're just using RStudio like it's a calculator. So you're going to need a new script window and then your cleaned console there to get our output. Okay, so I gave you a couple of different examples just to get started. We have one binomial example and then down here a geometric example. So it says, suppose that you are a 65% free throw shooter. So our probability of success is 0.65. You are shooting 6 free throws in a row and each free throw is independent of the next. What is the probability that you will make exactly 0 free throws in 6 attempts and then 3 or less free throws in 6 attempts? So according to what I have right here, we can put that in RStudio. You don't have to put the green stuff in. That's our commentary. But we're going to use the function dbinom. The D stands for distribution, so it's a binomial distribution. You want to put how many you want to make. So we want to make 0, it said the first time. Then you're going to put how many trials you have. That's our n value, so size is equal to 6. And then our probability of success. And you can put 0.65 like I have on the example. You can also put 0.65. One of the things you're going to have to do for the lesson check and for the homework is you're going to have to convert these to percentage. So I'm going to go ahead and throw parentheses around this and say times 100 at the end so that I can make sure that it is in fact going to move the decimal 2 places to the right for me. So I got 0.18. If this were my problem that I needed to for a lesson check or homework, I would type in 0.18. Let's see if we get the same thing using our calculator. So again, we're trying to get exactly 0 free throws. So we would use second vars, binom PDF, because precise means exact. Number of trials is 6 attempts. Probability of success is 0.65. And then we want to make 0 free throws. We always do our times 100 to make it a percentage. So notice that we do in fact get the same answer. Okay. On to the next one. We make 3 or less free throws in 6 attempts. So we're going to grab all that. And according to this example here, the following will sum up the probabilities between the two values provided. So I want 3 or less. So if I put 0:3, then it's going to find all of those probabilities. Let me show you. If I don't put the times 100 and I don't put sum in front of it, I want to show you what it does. So it's finding the probability of 0, the probability of 1, the probability of 2, and then the probability of 3. So we know we want the sum of that. So you're going to use the function sum. You're going to put the whole function dbinom in parentheses. So you're saying take the sum of all of this. I'm going to add one more parenthesis before my times 100. So I want it to do the dbinomial from 0 to 3. I want it to add all 4 of those numbers up for me. And then at the very end, I want it to multiply by 100 so it changes it to a percent. So I would be reporting this as 35.29. So let's go see on the calculator how we used to do that. So we would use binom CDF this time. And we want to do 6 trials, probability of success 0.65. And to get 3 or less, you would put a 3 in as your X value. And so your calculator knows to get 3, 2, 1, and 0 all added together because it's a cumulative function. And then, of course, we'll do the times 100 to make it a percent. And notice we still get that 35.29. Okay. So geometric gets a little bit more confusing for students. This is why I put this after the test, because I didn't want it to confuse you as you were using your graphing calculator. So let's take a look at what we do for geometric. So for geometric, it says, and I really am probably going to come in here and change these notes because it really is not X that you're putting in. It's actually X minus 1. And you'll see that I did that automatically with this problem. So Coach Holtum is an awesome dart thrower and can hit a bullseye 35% of the time. So his probability of success is 0.35. He is throwing until he hits a bullseye. So we don't have a fixed number of trials. Therefore, it is geometric instead of binomial. So what is the probability he will throw the dart 3 times? So for geometric, the function is dgeom. And we're going to go from, it's really weird, guys. The wording is that you're going to put the number of how many times you want him to fail before he succeeds. So if he's going to succeed on the 3rd time and hit the bullseye, then we want him to fail 2 times. So the number that we're putting there is actually how many times we want him to fail before he has that successful bullseye. And then probability of success is 0.35. So I know y'all are like, there's no way this is going to give us the same thing the graphing calculator would, but I'm going to show both ways and you'll see. So if you know about your graphing calculator, which most of you do, when we want exactly 3 darts, we would do geometric PDF, because we don't know the number of trials. So we would go into geometric PDF. His probability of success of hitting that bullseye is 0.35, and we would put his X value to be 3 on the graphing calculator, not 2, like our studio wants. And of course, the times 100, and it does, in fact, give you the exact same answer. So this is why, right here, this is why I held off letting you use our studio on the probability test, because I didn't want this to confuse you. So if you're using the calculator for geometric, you're going to put the exact X value that you want. If you're using our studio, then you're putting how many failures you want before that first success. So you're always going down by 1. So if we want the next one, the probability he will throw the dart 4 times or less, then he's going to throw it 0, 1, 2, or 3 before the 4. So that's why it's going from 0 to 3. And that would be that he is successful on the 4th or after. And so we want him to fail 0 through 3. Man, that's confusing. But anyway, we got this. We'll practice and it'll start hopefully clicking for us. But we're going to go from 0 to 3 this time, not 32. 0 to 3 with probability 0.35. Remember, you do have to put sum in front of there, so it takes the sum of this for you. So we're going to end up needing another one there and then another one here in order to get it to do the times the percentage. I know you're really doubting me out there, some of you guys, so let's try it on the graphing calculator. If we were doing 4 times or less, we would do geometric CDF. 4 times or less. So probability of success 0.35, X value would be 4, because 4 times or less, we would do times 100 to get our percentage. And look at that, same answer. I hope you're starting to believe me. Hope you trust me. Let's run through the lesson check with these ideas in mind, okay? So these first 2 things, I'm just going to say this was notes, 9.6 notes. And then now I'm going to start the actual lesson check problems, kind of just using those as a guide. So I might do some copying and pasting. So suppose that you are a 65% free throw shooter. You are shooting 6 free throws in a row. So we have a fixed number of trials. So I know off the bat that's binomial. Each free throw is independent of the next. So we're going to do some exact ones, it looks like. So I'm going to copy my line 2. My line 2. So we want exactly 0 free throws. Remember that for binom, it's really just like you do it in the graphing calculator. So we can put the 0 there. We had 6 free throws, so our attempts is 6. Our probability of success is 0.65. So we've done this. I'm just going to run it. And then the next one we would do is make exactly 1 free throw. So we would just change the 0 to a 1 and run it. Uh-oh. What did I do? I lost my parenthesis. There we go. And then I would run it with exactly 2. And then last one here, exactly 3. Okay, so let me go type these answers in, just kind of double checking. So this one we got to be 0.18. The next one we got 2.05 when we do 2 decimal places. And then exactly 2 free throws. That one is going to be 9.51. And then last but not least here we have 23.55. Okay, so 3 or less. So now we're going to use this one as a guide, and I know it's the exact same problem. That's okay. We're going to use it to help us with the next ones. Where RStudio shines over using your graphing calculator is on this next one. I'll show you. This one is what, 35.29. Okay, so on our graphing calculator, we can't do 2 to 5. What we could do maybe is find the binom CDF of 5 and below and then subtract 2 and below. Let's see if this will work. Not binom. Is it binom? Yeah, we're still on binom. Binom CDF of trials 6, probability of success 0.65, and we're going to do 5. Get an answer, and then we're going to subtract 2 and below. So binom CDF, and you guys didn't have to do anything this complicated on your test. You're welcome. But if we're trying to get rid of, let's see, let me think about this a second. I might be putting the wrong numbers in here. 2 to 5. I actually want to just subtract 1 and below. I want to keep 2. So I'm going to subtract 1 and 0 from binom CDF of 5. Because if I do 5, remember that for CDF, that includes 5, 4, 3, 2, 1, 0. So if I subtract 1 and 0, that's going to leave me with everything between 2 and 5. I know this is crazy. And I would multiply by 100. So wish me luck. I think that RStudio does this much quicker and easier if I just say my first number is a 2, my second number is a 5, and please run it for me. And it's same exact answer, guys. So much easier using RStudio than trying to figure out how to set it up on the graphing calculator. So we're going to type in 90.23. Okay, so the next one, 4 or less free throws. 4 or less. Wouldn't that just be like this one up here? I'm going to copy that one because all we would have to do is change the 3 to a 4. 4 or less does include that 0 there. Okay, and so we got 68.09. Alrighty, and then less than 6 free throws. If we want less than 6, then that's going to go from 0 to 5. We're not actually going to include the 6 because 6 is not less than 6. So I'm going to go from 0 to 5. Love copy and paste. So that one should be 92.46. All right, so no big deal. Not too, I hope, not too complicated for you guys. When we get to geometric, that's the one that stretches your brain a little bit. It won't hurt you. It's okay. It's okay to think hard. Okay, so question number 2, we're moving on to geometric now. This. So I'm going question number 2. So we are going to follow the geometric stuff. So instead of having to keep scrolling, I'm going to copy this down because I think we might actually start with those, aren't we? We will find out. So Coach Haltom is an awesome dart thrower and can hit a bullseye 35% of the time. Report as a percentage rounded to 2 decimal places with no percent sign. So he is throwing until he hits a bullseye. That's what tells you that it is geometric and not binomial because he doesn't have a fixed number of trials. So what is the probability that he will throw the dart 3 times? So remember, we do go down by 1, so this is the correct line of code to run, and we get 14.79. What is the probability he will throw the dart 4 times or less? So that was the second one that I did in the notes for you. So that one is 82.15. What is the probability he will throw the dart between 5 and 10 times? Okay, guys, can we do this? Can we do this? Control copy between 5 and 10 times. So if we're going to go 5 to 10 times, you're going to go down 1 on each of these. So instead of going 5 to 10, I know it's so weird, you're going to go 4 to 9. You're just going to go down by 1 on each one of these. And so that's going to be 16.50. I do believe if you put the 0, you'll be okay. I do believe if you don't put the 0, you'll be okay. Maybe not. You do need to put the 0, I'm sorry, because it doesn't truly round to 16.5 because that 4 makes the 0 stay a 0. Sorry. Go ahead and put 16.50. What is the probability that he will throw the dart more than 8 times? How do we do that? When it's more than, we're going to do the probability from 0 to 6, because we're going to go down by 1, but we're going to subtract it from 1. You're like, what? Okay, so let me copy this. Let me show you what I mean. So we're going to go, and I'm going to take this times 100 off for a minute. I'll come back to it. So we're going to do 1 minus the sum, and we're going to go from 0 to 6. So that's actually finding the 7th time. So then, since we're doing 1 minus that, then that's going to leave us with more than 8. Oh my goodness. Okay, and then all of this has to be multiplied by 100. Probably have way too many parentheses, so I'm just going to get rid of one of them because I got the red X. Let's see if this will do this for us. So we're going to go geometric distribution from 0 to 6. We're going to take the sum of that, and then whatever it gets, it's going to subtract that from 1. And then in the very, very end, it's going to say times 100. Somehow it still doesn't like that, though, because of this parenthesis up here. So I do need that one at the end. I'm actually going to put it back. Okay, let's see if it'll run it. So 4.90 should be the correct answer for that one. Okay, so I'm going to submit and hope for the best. And I got 2 out of 2. So if you followed along with me, then you should have 100% on your 9.6 lesson check. And so you guys do need to complete the 9.6 homework. And then we will get started with our final project after that. You will not have a test or anything over 9.6, the RStudio stuff. I do want you to try to do these on RStudio just for that practice, for that fun time. But we will not take another probability quiz or test, and you won't have to do anything more than just complete your lesson check, and then we will be done with our probability unit.